Bismillah, Assalamualaikum warahmatullahi wabarakatuh. This is tutorial for chapter 7.1 where we will be calculating the internal forces. Now, the questions that will be covered for this video is in the description box below. You can take a look at the PDF and see several questions there. If you are only interested in any particular question, feel free to jump straight away to that question. The timeline here at the bottom, you should be able to see the different question that is covered in this video. So feel free to straight away jump into the particular question that you find interesting or you want to watch for the tutorial. Right, so we will go into the first question. So this is problem 1. You can see the structure there, and the question states the beam AB is fixed to the wall and has a uniform weight of 1200 Newton per meter. If the trolley support a load of 6000 Newton, determine the resultant internal loadings acting on the cross section through point C and D. So if you take a look at the structure there, basically this question have two parts. One part is what is the internal load at point C. The other part is what is the internal load at point D. Right, so there's two portions there. So we have to solve one by one. So if you want to solve for point C, you can imagine that if you cut at point C, you have the portion from A to C as well as the portion from C to B at the end. Right, so you have two options. Either you want to focus on point AC or point CB. Right, and if you want to focus on the left side, which is AC, it is shorter, but you have to solve the support reaction first at point A. Right, so you have two steps there. Solve support reaction at point A and then solve point C. But if you take on the right side, all the forces are there. You have the load of 6000 Newton and no other forces, and you can straight away calculate the internal force at point C, right? So we'll try to do both. It should have the same answer as for the example in the lecture, but one is requiring one step further, right? So we'll use the right side first because that's the shorter one, right? So taking this is again, we are still solving for point C, right? So if we take the right side, we can straight away draw the free body diagram. So basically you'll have the longer part there, and then you have somewhere here the load of 6000 newtons, right? And okay, the length is, so you have 3 meter here and you have 4.5 meter here, right? 6 minus 1.5 is 4.5. all right, and now the length is important here because you have the density given, right? So of that 1200 Newton per meter, right? So we have the weight that you have to consider. The weight will be at the middle, right? So this whole thing is 7.5, so meaning the whole thing is 7.5 meter. So at the middle will be, because 7.5 is the whole thing, the middle will be 3.75, is it? Okay, right? Now so we're taking the right side, so we have the normal like this, shear going up and moment going up, right? So this is point C, right? VC, MC and NC. That will be your free body diagram. Hopefully everything is clear, right? So we're taking on the right side, we have to see what is the dimension, and because in this particular, okay, there's something missing, which is this load here. Okay, how to, okay, I'll take here, right? Because we don't have enough space, so okay, here. So basically we have one 1200 Newton per meter times 7.5 meter. And if you calculate this, you will get 9,000 Newton. 9,000 Newton at the middle point there. So the distance, okay, this distance that I erased earlier is 4.5 meter. Alright. So if this is the free body diagram, then we have everything that we need, right? We have 3 unknown, nothing else, so we can have 3 equations, 3 unknown we can solve. Alright, so if you do summation of fx equal to 0, taking to the right as positive, we don't have anything, right? So negative nc equal to 0, so nc equal to 0. That's the answer. Summation of fy equal to 0, if you take positive upwards, so you have vc, you have minus 9,000, you have minus 6,000 equal to 0, so vc equal to 15,000 Newton, right? And if you take moment, right, so in this case, let me take clockwise as positive, summation of moment about point C equal to 0. So MC, so positive, right? So positive, if we take 9,000 first, 9,000, the distance is, what is it? 3.75 meter, and then plus 6,000, the distance is 4.5 equal to 0. So MC obviously will get negative value, so it will be negative 60750 Newton meter, right? 60750. Is it correct? 9,000 3.75, 6,000 4.5. Alright, so that will be the answer. Straightforward if we take the right side. Okay, hopefully no question. If you have any question, please do write in the comment so that I can attend for the question if needed. Obviously, if you have the slide or the solution for this kind of question, normally when you have something like this, they tend to, because they will like to have 3 significant figures, right? So this will become 15 kilonewton or 15.0 kilonewton. This will be 60.75 kilonewton meter, right? So that's just the change of the unit, right? So now we will try to address the same question, the same part, which is still internal loading at point C, but using the left side. Okay, so if you do it, because I do not have enough space, so I erase this one. Hopefully you take note of the answer already. So if you take on the left side, we have 2 steps. One is to solve for support reaction first. To solve for support reaction, you have to draw the whole thing and solve the whole thing first. So you have, oops, okay, this marker is already, okay, the whole thing is like that. And then you have 6,000 Newton there, right? And then at the middle you have the weight. So now if you take the whole thing, yeah, if you take the whole thing, it is 9 meter, right? The whole thing is 9 meter, 9 meter, the whole thing. So meaning that at the middle here is 4.5 meter, and meaning that based on the density of 1200 Newton per meter times 9 meter, you get 10,800 Newton. Okay, and the distance to 6,000 Newton, this distance is 6 meter. Okay, so and then because the point A is fixed support, so you have, let's say, AX, AY, and MAX, right? So for fixed support, as we have covered in the previous chapter, you will have force Fx, force Fy, and moment. Right, so solving this one, so okay, let's use, okay, summation of Fx equal to 0. Then you'll have, okay, then Ax equal to 0. Summation of Fy equal to 0 upwards. Now, so you'll have Ay minus 10,800 minus 6,000 equal to 0. So Ay equal to, yeah, terima kasih. So Ay equal to 16,800 Newton upwards. And then if you calculate, where should I put it? Let's use which side? Okay, let's use down here. So summation of moment about A equal to 0. Let's take clockwise as positive. So you have Max, because I assume it clockwise, right? So okay, Max, okay, the answer will be negative anyway. So plus 10,800 time distance of 4.5 plus 6,000 time the distance of 6 equal to 0. So Max in this case will be negative something. So if the calculation is correct, you get 84,600 Newton meter. So having solved the support reaction, now we can actually go to actually solving for the internal force at point C, right? So we will be drawing the free body diagram of section AC, right? So we'll have that section AC. Yeah, the support reaction is already determined. So Ax is 0, Ay will be upwards 16,800 Newton. Max will be counterclockwise, so counterclockwise 84,600 Newton meter. So the whole thing is 1.5 meter. So this is 1.5 meter, meaning the weight which is at the center will be 1200 Newton per meter multiplied by 1.5 meter, so it will become 1800, right? 1800 Newton. So next is the unknown here, so we'll have normal, so VC and C and also MC. Alright, so solving for this unknown, so if you do summation of Fx equal to 0, so we'll get NC equal to 0 there. Then if you use summation of Fy equal to 0, if you take upwards as positive, you'll have 16,800 minus 1,800 minus Vc equal to 0. So Vc will be 1,500, right, Newton. So that should be the same. Vc is 15,000 Newton or 15 kilonewton. And then if you want to solve for MC, so summation of MC equal to 0 if you take counterclockwise as positive. So you'll have MC, you have plus this one 84,600, 84,600. Okay, this one will be negative, so minus 16800 times the distance of 1.5, and then this for the plus 1,800 distance of half of 1.5 is, which is 0.75 equal to 0. Can you still see on this side? Hopefully you can still follow, right? So this one, if you calculate this, MC equal to, so basically just to check, 84600, 16800 times 1.5 minus or plus 1800, 0.75. So you will get minus 60,750 Newton meter. So that will be the answer there. So the answer will be the same, be it you take on the left side or the right side. The difference is the length of the calculation, because in particular for this problem, if you look when you cut at point C, if you want to take the left side, you have to solve for support reaction first. If you take on the right side, there's no need for support reaction. So that's why it is shorter. Now, please remember that if you have this kind of question in the exam, write first what is the final answer that you have to find. Because if you still remember, looking back at the question, you have to actually solve for point C and point D. And we only have shown how to solve for point C. Of course, if we have chosen the right side, it's not as long as this one. But I'm just illustrating that either way, the answers should still be the same. Alright, so we'll erase this and go for how to solve for part D. Alright, now, so refreshing the structure there, and now we are focusing on solving what is the internal force at point D. So again, if you cut at point D, you have two options, either to take the left side or the right side. Obviously, if you cut at point D and you still want to take the left side, you really like challenges, I guess, right? So because it's easier just to take on the right side. So we'll solve that one first. If you just take on the right side, right? So if you take the right side, meaning is section DB, right? So if you take section DB, there's no external force there, but you have, again, remember the density, which means it have the weight going down. So the whole thing is 1 meter. So this one is 1 meter, meaning that it will be 1200 Newton per meter times 1 meter, meaning 1200 Newton. And it is at the middle, so this distance will be 0.5, right? So if you cut at point D, so you'll have something like this, right? This is VD, MD, and ND, right? So if you want to solve, straight away summation of Fx equal to 0. So you have minus ND equal to 0, so ND equal to 0. Summation of Fy equal to 0, upwards as positive. So you have VD, VD minus 1200 equal to 0, so VD is 1200 Newton, and then summation of moment D equal to 0. If you take clockwise as positive, so MD plus 1200 times 0.5 equal to 0. So MD equal to minus 600 Newton meter, right? And there you go. That's full answer there, right? So yeah, that's the answer. Of course, again, if you now why in the tutorial I still want to show both way, even though why not just show this one, it's easier. It's just to show you if you need to actually calculate for the other side, you still know how. Even though if you have the option, you will always choose the easier one, right? But in the exam, sometimes the structure given may, you know, be in a way that you actually have to solve a complicated one. So for, you know, just polishing your solving skill, try to do both, so that either way you know how to do it, right? So I'll erase this one and we'll consider solving on the left side. Now to solve on the left side, we have to first solve for the support action at A, but when we solve for part C, we already have solved support action at part A, right? So it's the same value. It's basically, if you just check back what we have done before, AX equal to 0, AY is 16800 upwards, and the moment at point A is 84,600 counterclockwise. So we have done that. It's going to be exactly the same because that's the support action of the same structure. It is not affected by afterwards we want to cut where, right? It's about the whole structure. So I'm skipping on how to solve support action at point A because it's exactly the same. We have done this just before, right? So we'll go straight to drawing the free body diagram from A to point D. So if we draw the whole thing from A to point D, we have already established that AX is 0, AY is 16,800 Newton, and moment is 84,600 Newton meter. We have established that one, and then we have the 6,000 Newton there. Now the distance now will be 8, the total distance, right? 8. So at the middle we have 1,200 Newton per meter times 8 meter, so you'll get 9600 Newton. So in terms of the distance, this is 4 meter, and this one is 6 plus 2, right? Which is 6. Okay, the 8 is the whole thing, right? Okay, I almost make a mistake there, so be sure to double check because the whole thing is 8, 6, 9 minus 1, so 8. This one is 6, this one is at the middle, which is 4. All right. So okay, we haven't drawn the support, the internal force. So this is on the left, so you have VD downwards, MD, and then ND. Right. So summation of Fx equal to 0, taking to the right as positive, so you'll have ND equal to 0. That's the answer. Summation of Fy equal to 0, taking upwards as positive, so you have 16800, and then you have minus 9600, and then you have minus 6000, and then you have minus Vd equal to 0. So in this case Vd equal to, so just to double check, 16800 minus 9600 minus 6000 minus Vd, so Vd becomes 1200 Newton. Summation of moment about point D equal to 0. So I'll take counterclockwise as positive, so MD there, then plus for this one, plus 84600. Okay, this will be a bit longer, right? So minus 16800. What is that distance? Okay, our distance should be from there. Okay, so then what is that one? This is 2, right? This is 2, and then this one is 4, right? Okay, so 16800 is the whole 8 meter, so times 8, and then we have plus 9600 times distance of 4, right? 4, and then plus 6000, the distance of 2 equal to 0. So here you'll get MD equal to, so double check, so MD plus 84600 minus 16800 times 8 plus 9600 4 plus 6002, you will get minus 600 Newton meter, which is the same as before, right? So either way we'll get the same answer. As mentioned, one tend to be a longer calculation than the others, but in term of course, in term of exam and even in the real solution, we will select the shorter, easier calculation, obviously. But in term of planning, training and doing exercise, please try to do both so that you know what to do if you need to. Alright, so that's problem number 1. We move on to problem number 2. Okay, so this is problem number 2. We have the diagram and the question states, determine the resultant internal loadings on the cross section through point C. Assume the reaction at support A and B are vertical. Right, so the support reaction, not sure what that type of support reaction is that, but the question already state that it is vertical, right? So the diagram is there as usual. So in this question, we have to cut at point C. So if you imagine cutting at point C, you have two options, right? Either to take on the left side, which is A to C, or to take the right side, which is C to B. Again, for exercise, we'll try to do both and confirm that the answer is the same, so that we know how to deal with both circumstances. But either way, we have to actually determine the support reaction first, right? If you want to take on the left side, you have to find what is the support reaction at A. If you want to use on the right side, you have to find the support reaction at B, right? So let's solve for support reaction first. So if you draw the whole thing from A until B, so at the end here you have 6 kilonewton, and then you have that triangle there, right? So okay, the triangle is over the span of 3 meter. So in terms of the placement, then it will be 2 meter here, right? And then this is 0.5. So you have 3 meters, so 2 meter and 1 meter here, plus 1.5, so 1.5 meter here. Right, so the total is 2, 3, 4, 4, right? 3, 4. All right. So the value is this one is what? Half times 3 kilonewton per meter times 3 meter equal to 9 divided by 2, 4.5 kilonewton. Alright, so okay, support reaction, it says that it is vertical, so you'll have, let's say, AY and you have BY. So let's take, for example, summation of moment about point A equal to 0. Let's say counterclockwise, so we'll have B times 4, and then wait, okay, this one, so minus that one, 4.5 times distance of 2, and then minus 6 times distance of 0.5 equal to 0. So B equal to, so what is 9 plus 3, 12, divided by 4 becomes 3 kilonewton, is it? Okay, and then if you do summation of Fy equal to 0, outputs as positive, so you'll get Ay, this is By, right? So you have Ay minus 6 kilonewton minus 4.5 plus By, which is 3 plus 3 equals to 0. So in this case, Ay becomes, what is this, minus 10.5 minus 7.5. So bring to that point 7.5 kilonewton. So that is the support reaction, right? Oops, I'm out of the frame. Okay, support reaction. So By is 3, AY is 7.5. Now having that, then we can solve by either taking to the left of point C and to the right of point C. So I think I will erase this one, just hopefully you take note already, BY and AY. Now looking at the diagram there, let's try to take on the left side first, right? So if you take on the left side, this is the left side. So on the left side, AY is already calculated at 7.5 kilonewton, right? And then we have downwards at the middle of 6 kilonewton, and then nothing else, and then you have VC, is it point C? VC, MC, and C. So in terms of the distance, so this is 0.5 meter, this is 1 meter. Okay, so if you do summation of fx equal to 0, you will get nc equal to 0. If you do summation of fy equal to 0, then you have 7.5 minus 6 minus Vc equal to 0, so Vc equal to 1.5 kilonewton, right? And then if you do summation of moment about point C equal to 0, you take counterclockwise as positive, so you have MC, and then plus 6 times 0.5 minus 7.5 times 1 equal to 0. So you'll get MC equal to, this become 4.5, right? 4.5 kilonewton meter. So that is the answer. Now if you take on the right side, is there enough space? Okay, let's try. So on the right side, BY is already calculated at 3 kilonewton, right? And then we have one loading from the triangle, right? So it's basically here, we already calculated before, which is half times 3 times 3, which is 4.5 kilonewton. The distance is 2 meter here, 1 meter here, right? And then we have the shear, which is VC, MC, and C. Okay, so okay, this is 1 meter, this is 2 meter. Sorry for the bad handwriting. So if you do summation of fx equal to 0, you take clock positive to the right, so you have minus nc equal to 0, so nc equal to 0. If you take upwards as positive, summation of fy equal to 0, you have vc minus 4.5 plus 3 equal to 0, so vc equal to 1.5 kilonewton, which is the same. And then if you do summation of moment about point C equal to 0, if you take clockwise as positive, because it's clockwise, I'm using that direction, so MC, this one plus also plus 4.5 times 1, and then minus minus 3 times, what is this, 3, right, equal to 0. So 9 minus 4.5 become MC equal to 9 minus 4.5 kilonewton meter. That is the same with this one, right? So again, we have shown that your NC 0, VC 1.5, 1.5, and MC 4.5 is the same either you take on the left or on the right. Yep. Of course, in the exam, you just, it's only this one or this one. There you go. Right. Okay, so that is problem 2. Let's go to problem number 3. So this is problem number 3. We are given the diagram there. We have the force of 2000 Newton. And the question states, determine the resultant internal normal and shear force in the member at A, section AA, and B, section BB, each of which passes through point A. The 2000 Newton load is applied along the centroidal axis of the member. Right, so the diagram is there. So actually this is being cut at the same point, meaning the point A, the capital A, but at a different angle. One is just, you know, straight cut like that, and one is having a tilted angle. And in the lecture I did mention that this will have an effect to the normal and shear force, because normal is normal to the surface. So if it's surface like this, normal will be like this, so it, you know, accordingly, right? Okay, so even though the calculation will be straightforward, it's just that as long as you understand how to draw the free body diagram, right? So part A is when the cut is straightforward like that, right? So if you draw the free body diagram, this one is either way, right? If you want to take on the left or on the right. So let's take on the left. So if you take on the left, so the force will be 2000 like this, right? So 2000 Newton, and then it is cut straight, so you'll have this three, right, basically. So V A, M A, and A. Okay, but the question only asks for normal and shear, so NA and VA. So in this case, if you do summation of Fx equal to 0, taken to the right as positive, so NA minus 2000 equal to 0, so NA simply is 2000 Newton as expected. If you do summation of Fy equal to 0, taking upwards as positive, so we'll have minus VA equal to 0, so VA of course equal to 0. There you go. Okay, so for part B, if it's slanted that way, so is it too extreme, this one? Okay, it's 30 degrees, right? 30 degrees, something like that, right? So slanted 30 degrees, so basically this is 30 degrees, right? So in that case, this is the 2000 Newton. So we'll have the normal is there and the shear is there, right? So VA, right? VA and A. So of course you have the MA there, but anyway, so we are focusing on VA and NA. So in terms of calculation, you can straight calculate using X and Y like this, right? But it will be a simultaneous equation because both will have X and Y component. To make it easier, then let's just use this one, right? X and Y according to this axis. So that will be straightforward because we will not have simultaneous equation to solve. But if you want to use this one, you have to know what is this force in accordance to this, right? So because this is 30 degrees, so this will be 30 degrees, right? So this will be along X, and obviously this will be along Y, right? So X, Y. Okay, so with this one, so if you want to do this, you have to specify what is X and Y axis. Otherwise, if you do not draw this and suddenly you calculate using this, as an examiner, I would not know how to, and is it a mistake, is it a coincidence, do you copy someone? So make it clear. So based on this, if you do summation of Fx equal to 0, taking, you know, that direction as positive, right, at that slanted, so you'll have an A, and then this one will be that one, so minus 2000 cos 30 degrees equal to 0. So NA will be 2000 cos 30, which is 1732 Newton. And then if you do summation of f y equal to 0, then y is taking upwards that way. So you'll have this one, it will be having a negative direction, right? So it'll be negative 2000 sine 30 and minus VA equal to 0. So VA will be negative value of 2000 sine 30, which is so negative 1000 Newton, and that would be the answer, right? So this one is just to test your understanding. This is not much to test your calculation. It's more on to test your understanding of whether you understand where is the normal and shear force when you have, you know, the cut on the I don't know, on the member is at a slanting angle. All right, so that's problem number 3. Let's move on to problem number 4. Okay, this is problem number 4, our final problem for this section. So we have the diagram there. I know for some students this might seem intimidating, but you know, calm down, just, you know, take a breath, and then just look at what the question wants, and we move on step by step. All right, so going back, so you have the diagram, and then the question says the metal stud punch is subjected to a force of 120 Newton on the handle. So at the hand there you have 120 Newton. Determine the magnitude of the reactive force at point A and in the short link BC. Right, so this is basically like in the previous chapter where you have to find what is the force or support reaction, right? Also determine the internal resultant loading acting on the cross section passing through the handle arm at D. So meaning that we will have to cut at point D. So this question actually have two parts. One is what we have covered in frame and machine in chapter 6, which is meaning the first part. The second part is chapter 7, which is, you know, cutting at point D and finding the internal loading. So of course the question have two components there, so we will cover both. All right. So of course the first part is basically to refresh whether you still remember how to solve for chapter 6, right? So now in reality, because when we cover all these chapters, it is for us to study component by component. In the reality, everything you know, exists simultaneously. You cannot say if you are working as an engineer, right? Okay, that one is from chapter what chapter is that? You know, there's no distinction like that, right? So anyway, going to this question, so the free body diagram will be on the handle throughout, right? So basically, okay, this one is interesting to draw. All right, so if I start at point A, right, so it is something like this, 30 degrees, right? And then it goes down perpendicular there, and then it goes back up like this to the handle there. And then this one is at a different angle, right? Oh no, it is 60 from top, so it's still 30, right? So something like this, right? Because, okay, let's identify the angle. So this one is identified as, oops, horizontal there. So this one is 30 degrees, and the other one, it give like, because it give over here, right, but it should be the same. It give, this is 60 degrees, right, meaning that this is still 30, right? Anyway, so the we have 2 points here. So one point A and point B, right? So point BC, you can straight away assume that one, It's either tension or compression. So let's say FBC, and at point A, obviously that is a pin support, so you have, let's assume that way, right? So AX, AY, we assume the direction, the distance, right? So this one is 50 millimeter, this length, and then the other length is 200 millimeter, so this is 200 millimeter, and then we have in total 150, so 150 millimeter here, and then the rest is 300 millimeter in total, and then we have the force of 120 Newton. Let me just write it more clear, 120 Newton. Okay, that's basically the whole free body diagram. Is it clear? Okay, hopefully you can still see clearly. Alright, so the first part is we need to find all of these three. And because we have three unknown, we have three equations of equilibrium, we can solve it. So the easiest one is just start with moment about point A. So summation of moment about point A equal to 0. Let's take counterclockwise as positive. So this one. Okay, this one then meaning we just find what is the perpendicular distance, which is the horizontal distance. So this one is counterclockwise of positive FBC times the distance of 50, then horizontal, so 50 sine 60 degrees, right? So they have perpendicular distance, and this one basically we just need to find, because it's basically along this, right? So if we have this distance here, this distance is perpendicular, right, to this one, or if I redraw it here, perpendicular there, right? So the whole distance times F times D, we can get the moment. So this one is clockwise, so minus 120 times the distance of 300 and 200 becomes 500. So 500 equal to 0, right? That's the only force outside of this one, right? So with this one, you can calculate FBC equal to, so if you calculate 120 times 500 divide by this one, you get 1385 Newton, or if you want to simplify in kilonewton, FBC equal to 1.39 kilonewton, right? That is simplified to three significant figures. Okay, having solved for this one, you can solve using summation of Fx equal to 0. Alright, so we have to use this angle then. So this one is 30 degrees, right? This angle. Okay, so if you take x component, this one doesn't have x component. So if you take positive to the right, so ax, no x component, x, and then that one have another x component, so plus 120 sine 30 degrees equal to 0. So ax, it will be negative according to this one, so negative 60 Newton, right? And then summation of Fy equal to 0 upwards as positive. So if you take Ay, then FBC already this one, so minus 1385.6 Newton, then minus 120 cos 30 degrees equal to 0. So Ay, if you calculate this one, you will get 1489.5 Newton, or 1.49 kilonewton, right? But anyway, because the question asked, I should have stated this earlier, right? Or take note of this earlier. The question says determine the magnitude of the reactive force at point A and the short link BC. So The question actually asks what is the magnitude at point A. So here we have the two components, right? So basically AX is to the left, so basically what we have is 60 Newton here, and then this one upwards, right? 1489.5 Newton. So what is this FR? FR at point A, right? So basically FR will be square root of 60 square plus 1489.5 square. Then you will get 1.1490.7 Newton or 1.49 kilonewton. Okay, so the resultant here is not so much different than this one because this X component is very small. But it's still in terms of Newton, if before you simplify, it's different, even more by a slight. Okay, that is still solving for frame or machine. This one is a machine, I think, right? Alright, so we haven't gone into actually how to solve for internal loading at point D, which is here, right? Because if you cut here, you have two options. One is to take on the left side, which if you want to take that one, you really like challenge in your life, right? Because this one you have to solve for support action first and then all these things, or you can take the right side. So we'll solve by using the right side, right? So I'll erase this one and I'll erase this one as well. So I'll straight away cut there using the same diagram. Obviously in the exam you cannot do this. You have to make a separate part, this is another part, and then redraw it, right? So but anyway, this one will be like this, and then this is 100 millimeter, right? 100 millimeter. So you'll have normal there, because this is on the right, right? So VC there and MC there, right? No, this is not D, this is D. So VD, MD, and D. So the question says determine the internal loadings on the cross section passing through the handle arm at D. It's something like that. Okay, so because from the drawing this is perpendicular, right? This is perpendicular, so it becomes straightforward if you use something like this, right? This is X, this is Y, let's say. So we use this axis, so that because this is perpendicular, right? So it becomes straightforward. So in that case, summation of Fx equal to 0, this slanting as positive, so the only thing that we have is FVD, right? ND is perpendicular, which is Y, this one is perpendicular, which is Y, so equal to 0. Okay, so summation of Fy equal to 0, which is this one, taking that way, positive, this one, so we'll have ND, then minus 120 equal to 0, so ND equal to 120 Newton. And then summation of moment about point D equal to 0. Let's take because it's clockwise, let's take clockwise as positive. So we have MD, this one MD clockwise, so this one is that point, no problem. So this one becomes clockwise as well, so plus 120. Of course this is perpendicular, so distance of 300 equal to 0. This is in millimeter, right? So MD will become negative, what is this, 36000, right? 36000 Newton millimeter, right? It's unit millimeter, Newton and millimeter, right? So, or if you want to simplify this, MD equal to minus 36 Newton meter, right? Yeah, that's it. So it is not difficult, coincidentally, because we take on the right side. You can try out taking on the left side. I think I do not know because that's quite interesting challenge there. but the answer will be the same. You can try, please do try to polish your skill. But if you focus on this one, it becomes easy because it is perpendicular like this, and this is also perpendicular. So of course, if you take horizontal as x and vertical as y, then it will be simultaneous equation. So hopefully you are familiar with trying to make things easy for your life and not making it difficult and miserable, so that the answer will become straightforward, right? So that comes with practice, because when you have enough practice, then it's straight away you can see, I can solve using this axis. And you have to state, you have to specify. You cannot simply, without stating anything, suddenly fx and fy. And even more so, some students write horizontal, and then but they are taking at the angle, right? So in the exam, that is just not, it is not corresponding to one another. Then it will not, you will not get the mark, because it doesn't make sense. All right, so that is problem number 4, the final problem for this tutorial. Hopefully you have understood these examples. There are other examples in the book where you have many different type of, distributed loading, etc. Please do try different type of questions, so that whatever comes, you know how to answer them. So with that, I think that's it for this tutorial for chapter 7.1. Right, so before, if you go to 7.2, where you want to find what is the function when you have to draw, right, the function along a beam, for example, it does require you to understand this part first, right? If you do not even know how to draw the free body diagram, if you cut at any certain point, then what comes next, it will be a mistake if you just assume something and it's wrong. So make sure you understand the fundamentals and able to draw the free body diagram. From there, the calculation is just using equation of equilibrium. Especially as well, if you are a mechanical student and you will learn mechanic of materials in the future in your study, make sure you understand these kind of things, because it is the foundation before you go there. All right, so thank you. Hopefully I did not make any mistake, inshallah, and hopefully this has been beneficial. So see you next time in the other class.